Hi everyone, and welcome back to this series of tutorials about application of WEKA as a machine learning tool to assess different power system assets. Okay, so what we are going to do today we'll try to do something different than what we have done so far. In all the data sets we have, we use the same data set, okay, and we use the tenfold way of splitting the data, and we got the classification or the regression accuracy based on this way of handling the data. However, the main objective of machine learning is to build a robust model so that you can bring any data outside this model completely and test it. And that's what we'll try to do today. We'll try to use the interfacial tension test data. This is from utility, I will call it utility A. And then I will bring another data set from utility B, which is a different utility, even in a different country, and use this utility B as a testing for the model to test or examine how good is the model. So this is the data set that I have. Now, A, this is the data set we had before. We have 1, 2, 3, 4, 5 features, and this is my IFT. Now, utility B has only 3 of these features. The DF and the color doesn't exist in the data set. Okay, so now we have two data sets. One of them has 5 input features, the other one has only 3 input features. Okay, so how to handle such practical problem? And this is what you expect. You don't expect that all utilities will have the same test. So we need to rebuild the model using the common 3 features. But before doing that, what I'm trying to do now, I will try to test the both data sets using the tenfold. So using one data set, let's say utility A, for the training and testing using the tenfold, and see what is the maximum accuracy I can get with these only 3 features. And then do the same thing for utility B. See how much accuracy I can get, and then I will merge the two together. Before that, let's remind ourselves, and this is the data set I will be using. I will be using the data set with only two output or two classes, good or bad. And if you recall, we had 95% accuracy using A and N with two hidden layers. So that is the accuracy we got using A and N. Okay, and the data set was the 720 transformers. Okay, and these are the two classes. It doesn't really matter the case, because what is most important thing here to show to you, when I have one complete testing data, what we will see. Okay, so we have very high accuracy here. Now let's move from here now, and let's go to WEKA. Let's open the data set now, and let's do the testing that, as I said to you. Okay, so now I will open the utility. So this is the utility A. This is the same original data. However, we have only 3 features: water, PDV, breakdown, acidity, and the I don't have the uh, DF or dissipation factor and the color. And here's the IFT is our feature vector. So let's go to the classification. Let's choose our classifier here. Functions, we'll use the ANN. Let's have this as two layers, hidden layers, two. Okay. And then let's start. So I'm getting 92.46 92.58%, or you can say 92.5%. So there is a drop from 95 to 92, and this is expected because we reduced the number of features. So maybe some of the features that we lost affected the accuracy. Okay, but not bad. From 95 to 92, it's not really a big drop. Let's go and open the other file. Now the other file, we have 327 cases, not 730. Okay, and again we have the same features: water, BDV, and acidity. Okay, so let's classify. Let's use the same classifier, everything the same. Start. So we got 87.5%. Okay, so that's a bit less than the utility A. So in utility B, when we use it, the same data for training and using the tenfold for testing, this is the accuracy. Now I did some other classifiers as well. No need to do it through WEKA. Let's just see the summary. So here we have and this is the 92% we have. I use SVM, I got 87%. I use KNN5, I use 89.8%. For the utility B, we got 87%, 83% using the SVM, and another 87% using the KNN5. So this is the accuracy, this is the level of accuracy I can get when I use each data individually. Now let's do the other thing, which is I will use data A in the training and data B in the testing. So let's here go to the data. Let's open our file here back. So this is our training data. Now I will go to classify. Now here, instead of using the cross validation tenfold, I will use supplied test set. Okay. So I will set here, open the file. Now I will use the utility B as our test set. Open. Okay. Close. Now I will use the same classifier. Okay. Start. Okay, now let's look here. The huge drop in the accuracy. Now here, this is the testing is done only what? Only on utility B. Utility A has no testing. Utility A is only for the training. And you can see here that the good case has too many misclassified. Actually, it is 58.9%. The accuracy of the good. For the bad, it was not bad, 94.5%. Total accuracy is 68.8073%. Okay, this is for the ANN. Let's try some other classifiers. Let's say KNN5. Okay, so let's try choose KNN. So we'll go to the lazy. We'll use KNN. Okay, and let's here, and this is 5. Okay, and let's do the classification. Now I need, every time when I do that, I have to set the data set. If I don't, then you will get an error. So open B, open. Okay, so I specify the classifier, the data set, then start. So we got 80.428%, way better than the ENN. Again, to the same point, we said that when you deal with machine learning, there is no rule that tell you that this classifier is better. It's based on the data. Okay, so here we have 78% in the bad and 81% in the good. So it is 80.42, which is not that bad, it's okay. Let's try SVM as the last classifier and see how much we will get here from the SVM function. So this is your SVM. Okay, again, I have to set the data, open the file, open, close, start. Oh, that's really good, 87%. So it's almost, we got the same result that we got when we train and test the same data set, utility B. Okay, now here this is 87. This is very, in my opinion, very nice data or nice results that I'm getting here. In the good, it has become very high, 94. There is a drop in the bad, which is around 70%. Okay, but total accuracy is 87.15%. Now you could do other things. You could mix a little bit between B and A, and if you do that, expect the accuracy to further increase. But what I try to show you here, when I bring completely different data, still your classifier can work, and that is, as I mentioned at the beginning, this is the optimum goal. The optimum goal is to build a robust model and then bring any testing data from any utility, from any customers, and then try to validate your system. So that's conclude our tutorial for today. Then next I will try to talk about different cases, different data sets, and how to deal with it. Till then, good night or good morning, depends when you are watching this video, and see you later.